We're going to solve this question here. We are given this equation and we want to show this expression here. So the first thing we can do is, usually when they ask us to show something, let's try to see how these two link up, because sometimes it's not clear where exactly we should start. So if we look at this expression that we want to show here, let's manipulate it a little bit, right? Okay, I'm gonna write blue. Whatever I write in blue color, you don't really have to include in your answer. It's just this is the thinking process behind some of the things I'm going to do. So from this expression that we want to show, we can actually write the 9 as 3 squared and the 4 as 2 squared, right? Over log 6. So over here, we can actually take this power and we can take it out. We can take it out and put it in front like that. So we get 2 log 3 minus 2 log 2 over log 6. This is quite a good hint for us to have, because later on when we manipulate this equation, we want to force this to appear, and that will lead us to this expression we want to show. Okay, so let's start with this equation here. Let me just copy down. So everything I write in red will be part of what I will write in my answer if I'm doing the exam. Okay, so what I'll do is I'll copy down the equation first. The next thing I'll do is actually I'll just directly log both sides, simply because I know that I'm expecting some logarithms to pop up, but there's no logarithms here yet. So let's just do logarithm first. So if I log both sides, okay, let me just write it out. So I log both sides, I will get something like this. Okay, so I get something like this. Actually, I don't really need a bracket here. Okay, so I get something like this. What I can do is actually I can take this power, I can bring it down, but let's take step by step. Let's try to break this into two logarithms first. So we recall, okay, so sometimes I'll write down some notes here to ask you to recall certain properties or certain things that you can do with logarithms. So recall that if you have log of a product, you can write it as a sum of logarithms, right? Or logarithm terms. So what I'm going to do is, instead of 2 to the power of something times 3 to the power of something, I'm going to write this as log of 2 to the power of something plus log of 3 to the power of something. Okay, and then the right hand side, I'm just going to leave it as is. Now I'm going to use another property of logarithms where I can, in a sense, bring down the power. So let's say I have log a to the power of n. What I can do is I can bring the n down, and I get log n times log of a. So what I can do is I can just, alright, I'll just point it out. I can take this power, put it in front, take this power, put it in front, take this power, put it in front. So let's do that. So x minus 2, I need to put a bracket around it. And then x plus 2. And then 2x log 6. Okay. Now that we have this, we want to take a look at what we want to show. Essentially, they want us to find what is x. So let me just expand this, because this is just like 2 numbers multiplied by log 2. 2 numbers multiplied by log 3. I'm going to expand everything out, throw all the x's to the left side, and then everything else on the right hand side. So if I expand this out, I should get something like this. Okay, so all I've done is expansion. Now what I'm going to do is I'm going to just shift things around. I'm going to throw all the x terms, so x, x, x. I'm going to throw everything to the left side. All the number terms I'm going to throw onto the right side. So what I'll have is x log 2 plus x log 3 minus 2x log 6 equals to 2 log 2 minus 2 log 3. Okay, this is because I have added this on both sides, so this side will, okay, I'll just write it out. If I add this on both sides of the equation, okay, then these two will cancel out. It will appear on this side, which is why I get this term. I'm gonna do the same for 2 log 3. I'm gonna minus on both sides. Okay, minus on both sides. So on the left hand side, it will cancel out. On the right hand side, it will appear over here. So I will erase all the blue color stuff, but this is just simple algebraic manipulation. And eventually I'll get something like this. Okay. Now I have all the x's on left hand side, no x's on the right hand side. What I'm going to do is I'm going to factorize out the x. So I will get this. Okay. Then what I can do here is actually to force out. Okay, I can actually just divide this first. Okay, let's just divide it first, and we'll see what happens. Because once you do that, you need a little bit of foresight on what. Oh, actually, I realized I forgot to write down the 2 here. So 2 log 2. Okay, yeah. So I'm gonna divide everything over. But what we need to do is we need to scroll back up and look at what is the expression we want to show. Because without really having a clear goal in mind, we can just leave it as is, or we can just like manipulate it certain ways, but we might not do it very efficiently because we need to know what we want to see. So in this case, what we want to see is a log 3 and a log 2 on top, a log 6 at the bottom, right? So we realize that we have 2 extra terms down here, but we can merge them together, right? We can just do like, let's say log A plus log B. That's actually equals to log A times B. Okay. Yeah, don't... Okay, I'll put a bracket to make it a bit clearer, but you don't really need the brackets here. Okay, so this is a property that we have used earlier on, but we just want to use it in the reverse way, right? We want to merge these two together into one term. So let me do that. After we merge into one term, which is log 2 times 3, which is 6. Now I have log 6 minus 2 log 6, which is like 1 copy of something minus 2 copies of something. In the end, I will have negative 1 copies of the first thing, of that thing. So I will have 2 log 2 minus 2 log 3 over negative log 6. This negative sign, I'm going to bring it upstairs. I'm going to multiply negative 1 to here, negative 1 to here. Eventually, I will get negative 2 log 2 plus 2 log 3. Okay, and then over positive log 6. Let me just shift things around a little bit because we are running out of space. Okay, so actually what we have here is almost what we wanted, right? Almost what we wanted. The only thing left to do is that actually nothing is left to do lah. We just need to swap these two around so that it looks exactly like what we want to show. So let me just shift these two terms around. Gonna put 2 log 3 in front, minus 2 log 2 behind, erase the plus, and this is actually the expression we wanted. Okay, so I'm just gonna put it here, and we are done. Okay, so let me just put an arrow here. Okay, now just to double confirm, let's scroll back up and see. Okay, yeah, I forgot to do something. So what I've shown is this form, okay, of this equation, right? I wrote it in a slightly different way for us to know what we want to show. But what the question is asking us to do is to write it in this form. But I know that I can backtrack to get what they want us to do, what they want us to show. So let me just do the backtracking. I will split this into 2 columns here. Well, yeah, okay, roughly lah. Okay, so from our here, okay, we got this working, right? This step, right? So unfortunately, that's not the last step yet. We need to backtrack. So we are going to bring the 2 in front into the logarithm to write it as a power. So 3 squared, then 2 squared over log 6. And then we're just going to evaluate the square. So it's 9, 4, and then over log 6. And we are done. Okay, let's go on to part B. Okay, so part B is a separate question where they ask us to solve this equation. In this part B, we want to take note of a few things just so that we don't get tricked or we don't make a mistake early on. This part, right? Logarithm y minus 2. This minus 2 is not, okay? So it's not inside the logarithm. So minus 2 is not inside the logarithm. Okay, logarithm function. Okay, so that's one thing. Next thing is that it's actually a clue. It's not something we need to take note of, but it's more of a clue. We have 2 different bases. And typically speaking, if we have a logarithm equation, having 2 different bases is not very fun to deal with, right? So what we want to do is actually to use change of base. Okay, change of base is required. And typically speaking, when we do change of base, let's look at the 2 different bases, 9 and 3. We know that 9 is 3 squared, so a natural choice would be to change both of them to base 3. This is already in base 3, so we want to change this to base 3. You can also change to base 9, it's just then you get a power of half somewhere, which is also fine. It's just I prefer to make things simpler, so I'll change to base 3. Okay, so let's copy out the equation. Log base 9y minus 2. So because the minus 2 is not inside the logarithm, I like to write it out a bit more like spread out so that is extra clear so I don't make any mistakes. Okay, so I get something like this. What I'm going to do is I'm going to do change of base first. So I'll just duplicate this first, and I'll show you how I do change of base. So I'm going to erase this term here that I'm going to do change of base. What I will realize is that 9, okay, it's a bit small. 9 is like a little bit lower, right? 9 is a little bit lower. Y is a little bit higher. That's just because 9 is like in the subscript and y is like normal. So 9 is a bit lower. I'm going to write down a fraction. I'm going to write log 9 below. Then log y will be above. And now I have basically done change of base. All I'm left to do is to choose what base I want. In this case, I want base 3. So let me just write down base 3. So change of base looks something like this. I think it's much easier to remember it as moving things around. So like the letter or the number that is a little bit on top, I'm going to move it upstairs. The letter or number that is a little bit below, I'm going to move it downstairs. Then I can choose any base I want, right? Or I can change to ln, right? Which is log base e. So this way of remembering things is a little bit easier than just brute force memorizing the identities and properties and things like that. Okay, sorry, not identities, properties. Okay, anyway, so something like this. And what I'm going to do now is log base 3 9. I can simplify this by writing 9 as 3 to the power of 2. So I'm going to again duplicate this. In exam, you don't have to copy the whole thing, because if the right hand side is always the same, then you can just keep writing equal, 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 but leave this blank. Only when you change something, then you need to write it down, right? Okay. So what I have here is 9 is actually can be written as 3 to the power of 2. And then I can bring the 2 out. You can skip a few steps if you want to. And typically speaking, when when you do exams, you might skip some simple steps. But what I want to do here is to show very clearly what I'm going to do. So I'm going to bring the 2 out, right? So maybe I draw a blue arrow here. I'm going to bring the 2 outside of the logarithm. And now, log base 3 is equals to 1. Okay, so recall that whenever you have log base something and inside the logarithm you have that same number, this is always equals to 1. It doesn't matter what's inside those blanks, like the squares here. Okay, so this is equals to 1, which is like log base 3y divided by 2. In that case, I'm going to multiply by 2 throughout. So I'm just going to multiply by 2 throughout the equation, right? So I will get log base 3y minus 4 equals to log base 2y, times 2. So 2 log base 2y. Okay, now once I get this minus 4, what I can do is I can write down, because I know log base 3 is equals to 1, and I want everything to be log base 3, what I can do is I can actually just multiply by log base 3, okay, which is actually just a 1, right? And what I'm going to do is I'm going to bring this 4 up here as a power. So I'm going to do kind of like the reverse of what I did the previous 2 steps. Okay, I will get log base 3y minus log base 3 to the power 4. Okay, I'll get this. Same thing also. I should bring this 2 up here. But when we do that, we have to be a little bit more careful, because in this case, we have log base 3. The whole of the 2y is going to get the power of 2. Okay, so we need to put the parentheses, the brackets here. Okay, now I have log minus log. Log minus log, okay, let's recall that actually log minus log, okay, so whatever the base is doesn't really matter. So log minus log, okay, is actually the same base, but the first guy over the second guy, right? The first argument over the second argument. Okay, so in this case, it'll be y over 3 to the power 4. So this is log base 3 y over 3 to the power 4 equals to log base 3 2y whole thing squared. Now I can remove the log base 3, but what I like to remind myself is that when you remove a logarithm, we take the base, which is 3 in this case, and we are going to exponentiate it, or we just put a big 3 down here. Okay, so this is how I like to write it out. You don't have to write down this 3, that's why I wrote it in blue. So the stuff in blue are actually things that I think about. I don't necessarily have to write it out if you don't want to in exams. You can if you want to. So you can write this big 3 if you want to. So essentially what I'm doing is I'm saying that the red color equation is the same as 3 to the power of left hand side equals to 3 to the power of right hand side. What happens is that the 3 and the log base 3 will cancel out, right? It's kind of like when you have a square root and you square it, you remove the square root. Something like that. So we, in a sense, unlock the stuff that is inside the logarithm. So we get this. Okay, now I know that 3 to the power of 4 is 9 squared or 81. So I'm just going to write it as y over 81. And then this is 4y squared. And I'm just going to skip a few steps. I'm going to take the 81 and multiply up here. So if I multiply up there, okay, if I multiply up there, 81 times 4, that will be 32, 4, 324. Okay. Now, this step here, you might be very tempted to divide by y, okay, which, okay, I won't say whether it's allowed yet. Let's scroll back up and see if this is allowed, okay. You can scroll back up to your workings and take a look at your workings, but I think it's always best to look at the question. In this question, they gave us log base 3 2y, okay, and log base 9y. Okay, either one of them doesn't really matter. Let's just use the log base 9y. So I'm just going to write down here that Okay, I'm just gonna write down here that since log base 9y is defined, okay, because it was in the question, it was given, so we assume that this is allowed, it's not illegal or anything. So if it's defined, what that means is y must be positive. Okay, so because y is positive, therefore I can divide by y. Okay, I'll just write in one line, divide by y. Okay, because we can divide by positive numbers, we can divide by negative numbers, but bear in mind, we cannot divide by a 0. So the most important part is to check if can y actually be 0? Is there a chance that y could be 0? In this case, it's impossible for y to be 0 because this logarithm log base 9y is defined. So because y cannot be 0, I can divide by y on both sides. So if I divide by y on both sides, the y on the left hand side will disappear. Right hand side, I'll get a y. I can also divide by the 324, I'll get this. In fact, I just solved for y, but actually, is that? Yeah, that's what we wanted. Okay, so we have solved for y. So what I'm going to do is I'm just going to just swap them. So y equals to 1 over 324. Just so that, usually we write the variable or the letter we're solving for on the left hand side, which looks a little bit more. Yeah, it's just by convention we write the letter on the left hand side. Okay, and that's all for this question.